Can you find the last digit of this Olympiad question? Oh no, I can't. 90% is going to say this. But after watching this video, you can find the last digit of even bigger expansion like this, and this in few seconds. Hello everyone, welcome back to Logic and Math. And without any delay, let's start our video. So our question is 2027 raised to the power 2028. Let's consider expanding it properly without going through the shortcuts. So when we expand this 2027 raised to the power 2028, we get this bunch of number which is about 6707 digits, and of which our last digit is 1. So the question is, do we really to go to the expansion and then find the last digit? The answer is no. We have just 6 approach to get to the our last digit of whatever big number it is. So let's consider for our case the number is 2027 raised to the power 2021. So the first step is that ignore everything except the last digit of the base. So our last digit is 7. Now it says second step, find the repeating pattern of the last digit. So 7 power 1 gives 7. 7 power 2 gives 49, last digit is 9. 7 power 3 gives 3, 4, 3, last digit is 3. 7 power 4 gives 2401, last digit 1. 7 power 5 gives 16807, last digit 7. So from here we determine that after 1 it started repeating cycle like from 7. So our cycle is repeating. So now we need to get the cycle length. So it's 7, 9, 3 and 1 is the cycle length of 4 digit. Now it says use exponent mode cycle. So our cycle was 7, 9, 3, 1 and 7. Here from here it started repeating. So it's saying use exponent mode cycle. It means our exponent is 2028 mod and cycle length is 4. As we have determined, cycle length is 4. So what this mod is actually saying? It's saying that when you divide 2028 by 4, whatever remainder you will get will be the answer of this expression. So 2028 divided by 4, it gives remainder as 0. Now it's what saying that pick the corresponding digit from the pattern, but there is no corresponding digit as of like 0. So here the case for 0. For remainder 0, consider the last digit. So here our last digit of the cycle is this 1. So for the expansion of 2027 raised to the power 2028, last digit is going to be the 1, and this is our expansion. See how easy this was. But in Olympiad, this type of question make us students uncomfortable. So let's consider another example to be very sure of our approach of finding the last digit. So here our last digit is through first step our last digit is 4, and we need to find the repeating pattern. So 4 raised to power 1 equals 4, 4 power 2 equals 16, last digit 6, 4 power 3 equals 64, last digit 4, 4 power 4 equals 256, last digit 6. So here you can see our cycle length is of 2, because after 2 digits, after 2 expansion, its last digit started repeating itself. So our cycle length is 2. Now we need to find exponent mod cycle length. So it is exponent is 289 mod, and the cycle length is 2, and this is going to be give remainder as 1. So from the fifth statement it's saying pick the corresponding digit from the pattern. So our corresponding digit from the pattern is first digit. So here 9864 raised to the power 289 gives the last digit
4 as our answer. And that's it. Now we are ready to solve these type of questions.
but here's the bonus that will definitely help you in the Olympiad. So our point is whenever the digit is ending with 0, 1, 5, 6, the last digit will remain constant. For example, if the last digit of any number 309 either 0, 1, 5 and 6, suppose consider the case of 0 and it is raised to the power n, it will always give the last digit as 0. 3095 raised to the power n always give last digit as 5, so it remains constant. Similarly for 987, 9867 and 6 raised to the power n always give last digit as 6, and similar for case is for the 1. Our second point is 4 and 9 have length of 2, so to keep in mind that 4 and 9 have the cycle length of 2, so we can directly divide exponents given in the question by 2 for if the last digit is 4 and 9, and leaving 4 and 9 all rest digits have the cycle of 4. In exam it directly we are going to find this exponent divided by cycle length. So I am very sure that this thing is going to give you better hand on the Olympiad questions.
Now, although
We have got the method to find the last digit, but if we are curious, then the question remains in our mind that why have we not considered the other digits and why only last digit?
we have got the last digit using mod 10. Any number mod 10 gives our last digit.
This gives another question that why mod 10? So consider a number a is equal to 10k plus the, for example 239, it can be written as 10 times 23 plus 9. So we can write every number in the form of 10k plus d. So now when we raise it to the power n, it can be written as 10k plus d raised to the power n. For our understanding purpose, let n is equal to 2. So this become a raised to the power 2 equals 10k plus d raised to the power 2. And when we expand this 10k plus d raised to the power 2, it gives 100k square plus 20kd plus d square. Now for any number ending in 10 will always give last digit as 0. This also gives last digit as 0. So it means our last digit of our expansion depend mainly on d, which is our last digit of the number. So that's why we have always considered this d for finding our last digit of a given expression in Olympiad. So if you have got this, then I have a question for you. You need to find the last digit of this expansion.
And drop your answer in the comment. So that's all for this video. Don't forget to hit the like button and thanks for watching.